Today we will see how we will find this kinematic indeterminacy of our structures. So to understand this, I will take up a problem. By doing this, we'll get to know what exactly is kinematic indeterminacy. Suppose I have a continuous beam. It is fixed at both the ends. I have a fixed support here, I have a fixed support there, and suppose I have roller supports in between. Moreover, I have a pin joint here. I have a pin joint here. You will see what exactly is a pin joint and how we will do this problem. So, kinematic indeterminacy means what are the possible displacements in a structural member. That's all. You remember this and you can find the kinematic indeterminacy of any kind of structure. Okay. So we'll see this continuous beam. We will find the possible displacements at each joint. Then we will add all those displacements, and that will give the kinematic indeterminacy of our system. Right. So here I have a fixed support. A fixed support. Is there any possibility of horizontal displacements? No. There is no possibility of vertical displacement. There is no moment. Then here I have a zero displacement that I will show here. Suppose I am having a fixed support, so it will restrict the horizontal movement, displacement, vertical displacement, as well as the rotation. These three are restricted in a fixed support. That's why it is zero. There is no displacement, so there is zero displacements, right? So coming to this joint, we have assembly support. So I will just write here assembly support. We have assembly support. It can restrict only vertical movement, but we can have a horizontal displacement and a rotation possible here. Similar cases here also. The vertical is restricted. We can have a horizontal displacement and we can have a rotation at this point possible. So total how many displacements at this joint? 2 displacements. Coming to this, it is same as that one. We have a horizontal displacement possible and a rotation possible. Then the total displacements are 2. Then we have taken it as 2. Now coming to the pin joint, there you will have, I will just write it down and then I will show you how exactly it is. There we can have a rotation at this direction. There is a possible rotation at this direction. There can be a rotation displacement possible in vertical direction, and there is also a possibility of displacement in horizontal direction. That I will maximize and I will show you how exactly it works. So just see here. Suppose this member, I am showing it with yellow color. This member is coming and joining with this green member. Now I have my green member. Here it is. I have my green member and here I have my pin joint. Suppose some load is acting on this part. So this yellow member may rotate in this direction, not even affecting this member. So there is a rotation possible in this direction. Similarly, see this green member, it may rotate in this direction. Then there is a possible rotation of this green member. And as it is a pin joint, there is no restriction for horizontal and vertical movement. Then there is a possibility of moving in vertical direction, and there is a possibility of movement, displacement in horizontal direction. So total, how many displacements are possible? 4 displacements are possible here. Right? 4 displacements are possible at that joint. So I'll just write it in blue color. Right? And coming to this joint, again it is a fixed support, so there will be 0 displacement possible. Now if I want to find the kinematic indeterminacy of this structure, this continuous beam, it will be 0 plus 2 plus 2 plus 4. Yeah, my kinematic indeterminacy is 8. That's it.